It's actually our last NFDI talk for this year, and I'm very happy that we are finishing the year off with a talk about Scholia, which is an open source tool that assists in exploring scholarly knowledge based on open data from Wikidata. Scholia provides a lot of profile types, each composed with multiple panels that render pertinent information based on predefined SPARQL query that is parametrized via the Wikidata identifier of the concept to be profiled. And it also facilitates collaborative curation of that information on Wikidata. And Scholia today is brought by us, by our speaker, Daniel Mietchen, who is one of the core developers of Scholia. He is trained as a biophysicist and works at the intersection of research workflows and web-based collaborative workflows, particularly via Wikimedia projects. And he's working as editor-in-chief of the open science journal Research Ideas and Outcomes. He's also part of our MaRDI NFDI consortium, which is the NFDI consortium for mathematics. And with this, I would hand over to you already. You will share the screen. You can also find the slides for those of you who already signed in early in the chat, but you will have them available also later.
Okay, I'm starting by sharing my screen.
Perfect.
Can you see that? Yeah,
yes.
So the slides are available on Zenodo. You can just take a screenshot of this and then find it there, or just search for my name, most recent, and then you can follow at your own pace. I'll try to get rid of the Zoom thingy here. And I'm actually using, I'm using slides here. This is the structure of the talk. Let me just minimize the Zoom bits here. Yeah. So first I'll give a very brief introduction into MaRDI, because that kind of motivates the interactions with knowledge graphs and Scholia. Then I will give a brief introduction to knowledge graphs. I know that many people in NFDI contexts are actually working with those, building them, but still I want to at least give a very basic introduction. Then I will outline the role of knowledge graphs in the MaRDI project. And then I will basically look at queries as windows into knowledge graphs, and then on how those queries can be made accessible and how they can be combined into profiles, and then the Scholia way of doing it, and also how Scholia is doing this in MaRDI. And yeah, if things work out, we should have time for a demo. And I welcome discussion throughout the talk, but I'm prepared to talk about 40-45 minutes and then to have a dedicated discussion. Okay. So first, intro to MaRDI. This is the, cannot really get rid of this Zoom stuff. Okay. It is the mathematical project within the NFDI landscape. And you see here the institutions involved, and yeah, the web address. And it has two main components I would like to highlight. One is the portal, which is basically the window into the MaRDI knowledge graph, or the landing page. And then the Scholia instance at MaRDI is a sub project of the portal, essentially. So I'm not sure. Can you see the title here? There should be mathematical research data. So yeah, what kinds of things does MaRDI deal with? It's different kinds of mathematical data, like symbolic data, numeric data, geometric data, mathematical models, also observational data, and yeah, texts. And all of these, they require different ways of handling, different ways of describing, different ways of bringing them together and interlinking them across data types. And some of them actually exist in other places as well, like numeric data exists in many disciplines. mathematical models and computational models are becoming more and more popular across different fields. Texts certainly exist in MaRDI, essentially in all fields of scholarship. But yeah, in some ways, mathematics has particular needs, and yeah, we're trying to address them in the MaRDI project. If you want to find out a bit more about these mathematical data types, here is a preprint that dives a bit into that. Yeah, here is a brief overview of the MaRDI project. So we are trying to link the math with the documents, with the models, with the software that is used to run the models and to compute the math, with the different data types that I just outlined. And the MaRDI proposal has more details on this and is also available online. Now, the intro to knowledge graphs. So here is a very basic depiction of how one can imagine a knowledge graph. This is actually from a more or less artistic installation in the Futurium Museum in Berlin, where the MaRDI team went last week. And yeah, what it does in a knowledge graph is it links different concepts. So here we have the concept for science, politics, protest, beliefs, knowledge, hopes, and all these other things. And they're interwoven and they are connected in various ways, not always as regular as here. And yeah, the point of a knowledge graph is that you have things that act as nodes, and then you have things that act as links between the nodes, and then you can basically walk along the graph from the Wissenschaft, the science, to the cultural diversity, and then there are different paths. Some of them are allowed, some of them are not, or possible, and so on. Okay, a typical structure of statements in a knowledge graph comes in the form of subject, predicate, object, and all of these are expressed as using standardized vocabularies. So for instance, a statement could be the planet Earth has the highest point, Mount Everest. And this can then, for instance, in Wikidata terms, be expressed Q2 for planet Earth, P610 for highest point, and Q513 for Mount Everest. This is just one possible statement, but so in a way, this links planet Earth and Mount Everest. But I can also say some other things. So for instance, I can link Mount Everest with the Himalayas using the relationship part of. So Mount Everest is part of P361 Himalayas Q5451. And I've marked the Mount Everest here in green because in one of the statements, it acts as an object, and in the other statements, it acts as a subject, which in terms of knowledge graph basically means it has links coming in from both directions, or one link comes in, the other one comes out. So you can basically travel to and from the Mount Everest in this knowledge graph. And so knowledge graphs are essentially built by connecting statements through shared nodes. They're the object of one statement and the subject of another. And yeah, in any individual node can be the object of many statements or the subject of many statements, or just even of none. Then it kind of doesn't really fit into the graph. And there are other kinds of statements that you might have where the object is not a node in itself, but for instance, you could have Mount Everest and then the height, and then this would be a concrete value. So that's called a literal. Or it could be like, what's the name of Mount Everest in a given language, like Nepali? That would then be a string. Or any of these things might have an entry in another database, and then we could have external links. And that would then link this particular graph with any other graph, so that the knowledge graphs can actually interact. And it's not necessary that all potential statements relevant to a particular knowledge graph are actually in that knowledge graph. Okay, so then knowledge graphs in MaRDI, we actually have a number of them. So one of them is the MaRDI portal, which tries to accumulate knowledge that is relevant to mathematics. So we have information about mathematical publication, mathematical software, mathematicians, mathematical formula, and we're gradually building a network of knowledge specific to these mathematical kinds of data and information. In building this portal and the MaRDI knowledge graph, we're taking a lot of inspiration and also software data models and general infrastructure from Wikidata. The idea here is to combine the specialist curation that we can get via the MaRDI portal with the community curation that we can get via Wikidata, which is about generic knowledge and editable by anyone. We also have some other knowledge graphs that are related to MaRDI. So for instance, algo data is a knowledge graph about algorithms and contains algorithmic knowledge and is specialist curated. And we also have the model order reduction wiki, which contains knowledge about like methods to make models more easily computable. And this is also specialist curated. But all of these, they can in principle interact, and we're building mechanisms for them to do so. This already works to some extent between MaRDI and Wikidata, and for the others, it's work in progress. Okay, now we can look into potential windows into those knowledge graphs. If you just see a network of links and that network of links has many nodes or many links, then it's very easy to get lost in that graph. And so we need mechanisms to look into it in a useful fashion. And this is what I call windows into the knowledge graphs, and queries are a typical way of doing this. You can imagine this basically like those Christmas calendars. So there's a certain tradition in certain parts of Germany that like the town hall or some other prominent building in the city is lit in the style of a calendar, and then every day one window is being opened and you don't really know what's behind. And in a similar fashion, a query into a knowledge graph can also open a window into that particular knowledge graph, and it can be different each time you run the query. Of course, if you run the same query, it should give you very similar results. But if you use different queries, then you might actually see different aspects of the knowledge graph. Okay, so here are a few queries to basically get us started, get us into the mood of thinking about knowledge graphs, both from a mathematical perspective and also more broadly. So we can start with queries that ask questions about mathematical structures. So for instance, I could ask for formulas that contain specific kinds of functions, like the sine function and the tangent function. And there is a query example here for the MaRDI knowledge graph. I could also ask about software that is mathematical, and so it is indexed in the SWMath database. And then I can basically ask the MaRDI knowledge graph for what it knows about such software. Likewise, I can ask the MaRDI knowledge graph for publications that it knows that are indexed in basically a very large repository of mathematical literature called ZBMath or ZBMath Open now. I can do an identical query in Wikidata or structurally identical query. But the results might be different because the publications indexed in one knowledge graph in MaRDI or the publications indexed in Wikidata might not be the same. Or even if they have the same publications indexed, the mapping to ZBMath might be at different stages of completion. Maybe the MaRDI knowledge graph is more or less complete than the one in Wikidata. But the point is, I can essentially ask very similar questions to different knowledge graphs, and I can coordinate that with external knowledge graphs like ZBMath. I can also try to combine, for instance, the mathematics with physics and chemistry by asking for the meaning of the symbol mu in various formulas. And so you can imagine different physical formulas, chemical formulas, and mathematical formulas where this particular Greek letter appears. And then it may not always be obvious for you when you first see the formula, like what the context is and what particular role this letter, this symbol is playing in that formula. And so we can basically run a query that does this for us. And at this point, I feel I basically should maybe show some of these things because we still have time. Otherwise, we can go back into this at the demo session. So now I clicked at this, and now we're running this query actually, and I'm limiting it to just 100 results. And so we now get a set of things that have formulas. I'll try to make this a bit larger. Yeah, where the letter mu is basically appearing, and it comes here with different explanations. So here it is the chemical potential, here it's the magnetic constant, and so on. I'll go back to the, okay. Yeah. So then we can also look at the correspondence between two knowledge graphs with respect to one particular type of information. So here I'm looking for authors that are indexed in the ZBMath database, and I want to know for a given set of MaRDI entries, which are the Wikidata entries for those. Or I can start from Wikidata and then go to MaRDI. But in any case, I'm using the fact that both of them can map to ZBMath, and I'm asking specifically for just those authors for which both know that particular ZBMath identifier. And so now that we're in this mood, I actually encourage you to think about your own questions that you might have, be it in mathematics or in any other discipline. The kind of questions that you would want to ask to a knowledge graph. And then we can think about how this could be basically structured, and also how, very importantly, we can get it out of the knowledge graph to actually work with this, to use it as input for research or education. Okay, so now how can we make these graphs a bit more accessible than the query that we just saw? And so here I pulled out another query. It shows us this query language that you've just briefly seen in passing, and it also shows us this query service here. And so basically, the query service is a mechanism by which we can ask the knowledge graph for certain things, and we have to use a graph query language that is aware of the structure of the graph, and the query service basically provides us with this possibility. We talk to the query service in that query language, which happens to be called SPARQL, and then it will return to us some results. I would like you to pay special attention to this line 2 here, because we're later coming back to it, because we're using this to parameterize. So while this particular query is about Ricci curvature, which has this particular identifier on Wikidata, we can change the query very easily by putting in another identifier, and then the query would essentially do the same thing just for that other entity. Why this is useful, we will see later. Okay, now I'm doing this, it's the same query. Let me just hop back and forth a few more times. It's the same query, and the only thing that changed is actually this line 2 and the identifier here. And with that, we do not get the query for authors who have published on Ricci curvature, but who have published on climate models. Okay, and now we can, of course, look at the results. I've shortened this to 5 so that it fits on this slide. We're keeping the same identifier and essentially the same structure for the query, but we get different results because the people who have published on Ricci curvature are not necessarily the same as those who have published on climate models. And yeah, But we do get some results, and actually those results we can appreciate even without knowing SPARQL or without knowing precisely how the knowledge graph works. And that is one of the elements that makes it possible to make the content of a knowledge graph experienceable to people who have at least some basic understanding of, say, mathematics or climate science or climate modeling, and who do not necessarily need to know all the specifics about how to build and maintain knowledge graphs. Okay, so with that, we can think about profile types. So what are the kinds of things that one might be wanting to profile? And so here we can start maybe with a topic, as I just outlined. So the topic could be something like Ritchie curvature. It could be something like a climate model. It could be the Zika virus. It could be anything that is a research topic in and of itself. And then, yeah, we can think about, okay, what kind of questions would we want to ask about a topic? Or we could say, well, maybe we want to profile authors, or we want to profile institutions or publication venues like journals, books, conferences, and so on. Or we want to profile publishers or events like conferences and workshops or awards, like someone's got a certain prize or a prestigious lecture or so. Or we might want to profile pieces of software or other methods being used in the research. And within the context of MaRDI, we're thinking about profiling also mathematical structures like formulas or algorithms. But in the broader context of knowledge graphs, you can think about other things as well. Essentially anything that is of a certain class of things that tend to be studied might well be worth its own profile. Okay, so now let's just consider a topic profile for a moment. What are the kinds of questions you might want to ask about a particular topic? So, for instance, one can imagine that you want to know the most recent publications on the topic, or the earliest publications on the topic, or maybe the most cited publications, or the most recent authors of papers on the topic, or the most frequent authors on the topic, or the most cited authors, or the most recently cited authors. Or you might want to have a map of relevant institutions. You might want to have a co-authorship network. You might want to have the topics that co-occur with your target topic, and so on. You can think about lots of other things. And here I'm jumping back. Now with that in mind, think about what kind of questions you might want to ask about an author, an institution, a journal, or a publisher, or a conference, or any of those methodological things, or any other things that are relevant in the research that you do or that you're in touch with. Okay, now to the Scholia way of doing it. Basically, yeah, the basic idea is very simple. Scholia is a web service that does this kind of profiling, and it takes basically two parameters in its URL. The first parameter is the profile type. So in this case, it's the topic. And the second parameter is the entity to be profiled, which should be of that particular type. You can also, or at least it should fit to that. Anything can be a topic in principle, even if it is a mathematical structure or something else. You can actually leave out this the first profile type, and then Scholia will determine on its own what the most suitable profile type is, because it makes use of the structured information in the knowledge graph about the thing. So Ritchie curvature would, for instance, still be mapped to a topic, but if we have, for instance, a profile that is dedicated to formulas, and the entry would be about a particular formula, then Scholia would forward this first to the formula profile, which doesn't exist yet. And then it would display that. And topic is typically used as a fallback. But we already have about 30 different profile types, including all of those that I've listed in the previous slides, and some additional ones like genes or pathways or species and things like that. And For each of these pages that are created this way, we have a set of queries of the same kind that I outlined above. Also importantly, we have, for most of those Scholia pages, a curation page that allows us to help the users curate and maintain the information that Scholia depicts and that is contained in the underlying knowledge graph. Okay, now how does Scholia in MaRDI look like? Essentially very similar. So whereas the original is hosted on Wikimedia servers, we're now hosting an instance of Scholia on MaRDI servers, but the mechanics are the same. The data are also the same, with the main difference that we try to adjust things for MaRDI purposes. So we have, we're exploring ways in which the profiles that Scholia generates can be made more useful for mathematics. And we do this in this separate instance initially. We also explore how the content that is in the MaRDI knowledge graph and not in the Wikidata knowledge graph can be exposed this way, or how the two can be combined by means of so-called federated queries. And we try to feed back all the changes that we make on the MaRDI instance to the original Scholia, so that the development of either of the instances can benefit both. Okay, now it would be time for the demo. We're about halfway through with the hour, and so I'll now switch to I'll switch to the maybe the original Scholia. And so from there, here, I would actually like to be driven by people in the audience. I will show some things, but I'm very happy to be interrupted so that I can show you things that are of interest to you rather than the things that I've prepared. Okay, so here you see, for instance, that's the table of contents for the Ricci curvature. It shows you that we're on the topic profile. It's also indicated in the URL. It repeats the identifier again. It pulls in the first few lines from the English Wikipedia if there is an entry about it. It points to two other tools that also allow for profiling. And it has this improved data button that shows or points to the curation page. Then it gives us the table of content with the kinds of things for which Scholia already has panels. The first one is a bit of context. So for instance, Ricci curvature is named after the mathematician Gregorio Ricci Corbastro. And it's an instance of a tensor field. And then we can see here most recently published works on the topic. Here it's important to note that Wikidata is maintained more or less by volunteers. And so the information here is not always complete. But anyone interested in the topic, anyone with knowledge on the topic can always come in and, for instance, check whether there have been any publications on Ricci curvature since July, and then update this. Or you also see that some things are tagged only with one topic here. Some have some additional topics. That is also its ongoing curation. You see here that there is a slight shift in the number of publications, not as dramatic as in many other fields. We also see here that the earliest publications on the topic. All of these things, by the way, are clickable. So from here, I would go to the profile for that particular work. Let's just do that. Now I'm on the work profile, also, as indicated also in the URL. And from there, I can get, for instance, to the original, like on the journal website. Yeah, there is a possibility for me to do author disambiguation. This is not too detailed, but I see a timeline. Let's stick to the topic profile for now. Here we also have, that was the query I had on the examples, people who are publishing about the topic. And from there, I can go to their respective profile. There's also some information that Wikidata knows is missing. And so, for instance, it might well be that this particular person actually has an entry in ORCID. It's just that Wikidata doesn't know which one that is yet. And so here's a tool that helps find that thing and make the knowledge in the knowledge graph more complete. We can also sort the authors in a more complex way. So this one was simply by number of publications on a topic. In this visualization, citations to and from are also included. So that makes for a more complex visualization, also sorting. Here's essentially the same data as in this graph, but in a different fashion, in tabular fashion. That makes it easier to click around. Then here we have the co-author graph. Yeah, the blue and orange is indicating gender. You might see that there is no orange in this field, which might actually mean that no females are prominent in terms of these metrics here, or that the information is just not curated in Wikidata yet. We have awards received by authors who publish on the topic, and each of these has its own profile. So we could, for instance, look at the profile for this kind of award, who got it, and here's some images of people who got it, or all of these are live queries, and so when you run on the same, you run the same profile in a few minutes or so, you might actually get different data because there's constant curation. And so this is the profile for the award. From there, you can find out about awards that people also received when they received this particular award. But let's go back to the topic profile again. So one other thing to consider for topics is the topics that co-occur with the target topic. So we're on the target topic for Ricci curvature. There's Ricci flow, there's Riemannian manifolds, scalar manifolds, other things, hypergraphs, harmonic functions. And they all co-occur in some way. This is not very well curated in Wikidata yet. We have, some of those for other topics. Some of those co-occurring topics might actually be something that has a geolocation. And then you would see a map here. Let's just briefly demo that. So if I just change it to, this is the Zika virus, then here I get a map of places where publications have been published that have the Zika virus and that other thing as topics, and that other thing like Madagascar has a geolocation, and so we can plot it on them. Here, this is something that I personally find very interesting, which allows you in principle to browse the literature by topic. In mathematics, this is not very well done yet, but this one shows the principle. So if the Bayes theorem was used in a paper, then this can be expressed on in a paper about Ricci curvature. This can be expressed here, and we can basically then, after a while, see what are the most commonly used topics or methods in the field of Ricci curvature research, and from there you could also zoom in. For the moment there's not too much to show, but for some other topics, especially biomedical ones, this is already much richer. Here then we see what are the places where research about Ricci curvature is being published. So the Journal of Differential Geometry, for instance, is very prominent here, and a few others. And from there we can go to the profile of the journal, which then gives us most recently published papers, then the most common topics in the journal, some images, and co-authorship. Here actually we do have some orange, citations, and so on. So also retractions if Wikidata knows about them. But back to the topic profile. So besides the venues, we also get information about citations, most cited papers, most cited authors. Again, this is all incomplete because the information in Wikidata is incomplete, but anyone with an interest in any particular topic can make it more complete, yeah, both alone and together with the community. Here we also have a map of organizations that are associated with works about the Ricci curvature. And yeah, as this is a rather small field and not very well curated on Wikidata yet, there is not too much to show, but for each of these, you would get like the number of publications and what that kind of institution is. So here the ETH Anturi is doing something as well. Then based on that, we can then compute the citation graph of works about the topic. This by itself is typically not very useful, but what it does is it shows us how complete the information is in this particular profile. So if we see only 4 countries, then it means that there is a lot of curation still to be done. But if there are many more countries, then the relationships between them are starting to make sense. But we have included this here because this particular query actually illustrates several aspects of the knowledge graph. So in order for this graph to, or this visualization to show any results, a number of things need to happen. First, we need to have papers about Ricci curvature indexed in the database. Second, they need to be tagged as being about Ricci curvature. Third, they also need to be tagged in terms of who their authors are. Then the authors need to be tagged as to what their institutions are. The institutions need to be tagged as to what their country is. The countries need to be tagged as to what the flag is. The flag needs to be tagged as to what the image is of the flag or how the flag looks like. And then finally, there needs to be a copy of that flag image somewhere on Wikimedia Commons so that this can actually be visualized in the graph. And so we're actually hopping multiple steps along the research knowledge graph in order to produce this visualization. Yeah. Now, let me go to the top again so that I can briefly show the improved data button. So this is something that we have on most Scholia profiles. And so what it does here is it already knows that certain kinds of information are incomplete on Wikidata. And so, for instance, there are 2 papers that have been tagged as being about Ricci curvature, and for which the author Alexandru Cristalli is just named as a string rather than an identified author. And so this curation page here allows me to go to another tool that then lists a number of papers that have the same string, Alexandru Cristalli, and I can then decide as to whether they are by the same author or not. And so here we have an entry already about this person. So we can check. They don't have any publications listed yet. But here it's a mathematical topic that they're associated with, doctoral advisor. Yeah, and so they, we have, yeah, so this all of this Ricci curvature. Okay, yeah. So this is the right person. Now the question is, which of these papers are we going to attach to them directly? Well, actually, all of these look very good. Riemann manifold, geometry, potential analysis. Yeah, all of these look very good. So that I can basically link all of these papers to that particular person, which means that not only these 2 here that are associated with Ricci flow directly will now be associated with that particular person, but it also means that a number of edits have now been made to the papers that we just had here on this list. And that also means that if we're lucky, we can go and look at the Scholia profile for that particular person. This may not work in the demo because there's typically a lag of up to 15 minutes. But hey, it worked at least in part. So when we started, this person had 0 publications indexed in Wikidata. Now at least 4 of those have already been indexed here. They are becoming visible on this profile. And so the curation that we've done, yeah, okay, here it's a bit more. Each of these queries is independent from each other. And so some of them might actually see a bit more or less into the knowledge graph because there are actually multiple search or multiple query servers that run these queries. And so within the 15 minutes or so, there might be slight differences between them. But after a while, this stabilizes and they give you the same results. And yeah, for each of those queries, each of these visualizations, we can go and check the original. This is the SPARQL query. And we can also do the same game that we did before. So if we want to change this to climate change or climate, what is it? Climate model is what we had before. We can do this here, and then we basically get something's wrong here. Bubble chart. Oh yeah, because this is a person, so I need a person. This is the author profile, not a topic profile. So let's do this. Yeah, and so now I'm getting the journals in which Paul Erdős was publishing and ranked by the number of papers he published in there. Yeah, we're still on the author profile for this person for which we just did some curation. And we see here that, for instance, on this map, a number of things already pop up. This was not our curation, but some other people. And we also see here the academic graph. And for each of these people here, they are in the knowledge graph. And so we could basically get their profile as well, and so on. Yeah, so I think this is roughly what I wanted to show in the demo. And now we have about 15 minutes left. And so I'm looking forward to questions and discussion.
Thank you very much. Are there already some questions? There are none in the chat so far. Some clapping in the chat. Maybe I can ask the first question to also break the ice. You mentioned earlier, if I have a query or a